Okay. Good evening, everyone. I'm Kamna Mishra from School of Mathematical and Statistical Sciences, IIT Mandi. And this is week 13, so basically the last week of this class. The course ended yesterday, but the today's class is all about the revision class. If you have any questions, you can ask, and we will go through just like in very short. We will go through just everything from the very starting, and we will do some examples. We will also go through the examples we have done before, so that it you can recall just everything, whatever is needed. Okay, so so this was regarding the last class. So now this is the week 13, and we have here the course of Essential of Data Science with R software, part 2, Sampling Theory and Linear Regression Analysis. And the instructor of this course is Professor Salam, who is from Department of Mathematics and Statistics, IIT Kanpur. Okay, so as I have said, this is the revision class. So till now, whatever we have learned, this class is all about that. So firstly, we will try to remember some basic R built-in functions we have gone through. Now, to have that, let me just go there. Okay, so in the very basics, what we have learned is that in the very starting, we have started with what is the data science, what is the role of statistics in that. The R softwares you all have installed, and the packages and library. The R function can be used as a calculator, so you can do multiple types of calculator, subtraction, multiplication, addition, etc. Then modulus, and then finding the remainder of something. Then it is not just for the scalars, so not just for just one value. You can done all these you can use R as a calculator for vectors also. So in the vector form, like you have an array or you have a vector, and then on that you can perform the calculation. So you can perform the calculation on vectors by this. So these are the basics, and then power operation. You can use the integer division, modulo division, and there are some other built-in functions. Now, to write the data vector, we take this. Now, in between this, you need to remember that this C is very important. If you will just directly write this, then minimum and maximum, these two functions will give you the same result, but the mean will not give you the same result. So the data vector needs to be written in the correct way to get the correct answer. So if you have not defined your data vector in a correct form, then it may be problematic if you perform any other operation on that data vector. Okay. The next topic we have here is that we can have sometimes missing data in our data frame. So for that, what we need is that we need to uh, further move further. So for that, what we need to do is that we need to use na.rm is equal to true. So basically na.rm, so remove na is for na not available or whatever. So for the missing data, you have na dot rm. So rm is for remove. So basically, we do this equal to true. So it will remove the missing data. The next is that the matrix. Okay, this is the problem. So let me just uh, give me just 2 minutes and I'll be back. Okay. Yeah. So I'm gonna just start. So till now I have just said that this one is the revision class. So we are gonna just go through some basics of it, and then we will try to do some questions. And if you have any issue till now in any of this class, then you can ask. Okay. So what we were saying is that. Uh, we have done this up to built-in function missing functions, missing data, sorry. So the next one is matrix and then data frame and then graphics and plot. Okay, so now the matrix operation. So firstly you need to know that how you can define a matrix. So that is, for that you need to give the data, and you need to give what is the number of rows and number of columns in your data. And based on that, you can define your matrix. And then you can have just a diagonal matrix. And for that, you can use this function diag. After that, you can use this transpose of a matrix. So to find the transpose, you can just do this. Now you have the operations. So you have the some operations like summation between two matrix. So that are mathematical operations with a matrix that you can do summation and then minus. This one is used, this sign is used for the multiplication. And for the division, you know that rather than a by b, we do not define the matrix division by a by b. We define it either it is a b inverse or b inverse a. So these two are different things. Okay. And then if you want to do the operations within a matrix, then for that you can use this. So basically you have this col means, and then similarly for row means, and for summation also you have this uh, syntax basically. Now, to access a row or a column of matrix, all you need to do is that write A, and then for that you just write in a square brackets what you want to access, which row, which column, or whether you want to have a submatrix. So basically, out of 3 by 3, if you want some 2 by 3 matrix or 2 by 2 matrix or 2 by 1 matrix, so you can have that submatrix also by defining that what are the rows and columns you want to access. Okay. Next is that so basically you can have two types when you have this. So even in the vector, so if you have data vector, so you can have the mathematical operation of vector with vector or with scalar. So here you also you have the mathematical operation with a scalar or the mathematical operation with a matrix, which we have just discussed. The next is the cross product. So for that, you if you write this cross product basically gives you the transpose of x multiplied by x. Now you need to remember that it is like other way around. It is not true in the matrix. Okay, so ab is not equal to ba. So multiplication is not uh, like done in this way. So when you do the cross product, it is not x multiplied by transpose of x, it is transpose of x multiplied by x. But the reason cross product is used is that when you have a large matrix, then it can give you the results faster than this multiplication. Okay. The next is concatenation. So basically, uh, you have a smaller matrix and one smaller matrix, and if you want to merge them, so you need to have a function to merge them. So for that we use the r bind or c bind. Okay, now that you need to remember that in r bind u binds row, and then c bind you need that column. Okay, so yes, this solve function, this one is used to find that inverse of a matrix, and as you know that the inverse of a matrix we can find only on the square matrix. So you need to have that for you need to have a square matrix to find that its inverse, and at the end you have that eigen dot. So if you will put that matrix, it will give you the eigen values and the eigen vectors regarding to that. uh, Now in concatenation, the important thing which you need to remember is that maybe there will be some questions based on that. uh, okay, so there are no questions for that. Okay, so the thing you need to remember is that when you have the R bind, and when you are basically binding the rows, so for two matrix, the number of columns should be same, because then only it can bind by this. When you have the C bind, you need to have that rows to be same. Okay, so let me just open that RStudio and we will see how it works. Okay, so here, okay, so if you have this matrix X, you can find its means by row means, column means. Let us say you have a matrix again Y. So Y is a diagonal matrix, you can see. So I have just defined tag for that, and the Z is the transpose of X. So this one is Z, sorry, this one is X. So Z would be this. Now, this is how you can take a submatrix. So you have X is like that, and to have the submatrix or to access the row or columns, what I have done is that, so 2 to 3. 2 to 3 is the first one before the comma. This one is for row, and after that is for column. So 2 to 3, so basically 2 to 3 row, so this one, and column is 1 to 2, so column is 1 to 2, so it is 5 6 5 3. So this one is your submatrix. Now this one you can do, this one you can not do, uh, uh, because you have X and you have Y. So it is 3 by 2, and this is 3 by 3. So you cannot multiply a 3 by 2 by 3 by 3, because the you need to remember always that if you are multiplying 3 by 2, 3 by 3. So this of the column of the first matrix and the row of the second matrix, these numbers should be same. If it is different, then we cannot perform the matrix operation. This one is the cross product. And you can see that this cross product of x is equal to transpose of x multiplied by x, whereas x multiplied by transpose of x is a different matrix. Now, okay, so the R bind. So basically, you have binded rows here. Okay, so you have a matrix and you have binded the rows. So you have the other matrix below this. So you need to have the number of columns same. So in Z and in Y, the number of columns are same. But you see the C bind, it is saying that number and of rows of matrix are not same. So if you have Z, if you have Y, so if I try to bind this by column, uh, okay, so if you want to bind this by row, so by row R bind, so this one is fine, these will come and this will come. But if you try to do the C bind, if you try to do the C bind, what will happen? This, okay, let me do all these things. Okay, if you want to do by C bind, what will happen? It binds this with this. So now, if you just want to remove this, you cannot remove this because here you have 2 by 3, here you have 3 by 3. So what will be the values of this? So you do not have these three values, so that is why the C bind function cannot work here. So uh, just if you will get a question like that, for the C bind, what is the necessity? Then necessity is number of rows needs to be same. For the R bind, number of columns needs to be same. So for R bind, number of, and in R bind, number of rows can be different. So as you can see, the number of rows here are different. Here there is 2 rows, here there are 3 rows. And for C bind, the number of rows, okay. So now this one is used to solve the x, and you can see that x is not a square matrix, so that is why it cannot solve it. So you can solve this, and then finally you can find the eigenvalues of this. So eigenvalues of this gives the value and the vectors. So these are the eigenvalues, these are the eigenvectors. So this is regarding the matrix. Then let us move to the graphics of it. So the graphics basically, you can have the different kind of plots. So you can have the univariate, bivariate, correlation plots, etc. So now, if you have this, let's say y1 and z1 are two vectors, so these are of same length, 6 and 6. And if you try to create one data frame, uh, x with y1 and z1, so you can see that when you have the matrix, then its dimension does not change, it just repeat. So x is this, so it is not gonna do that flat it is not gonna flatten the matrix and put it all in the one data frame, like put it all in just one column of data frame. What it does is that it repeats the matrix multiple number of times until uh, the the rows, the number of rows achieved. Okay, so you can see that we have the data from x, y1, z1. So x is 2, 3, 5, 6, 5, 3. So x is basically, you can see that it is in two columns, as here it is in two columns, and it is 2, 3, 5, 6, 5, 3. And since these are six, their dimension is just 6 by 1, so it is gonna repeat again to complete it. So it is 2, 3, 5, 6, 5, 3. So this is how your data frame will look like. Okay, now there is this, what you can do if you try to do library help equal to mass. What you can do, you can get uh, a lot of you can get firstly about the package, but what more you can get is in this package, you have these functions under this package. The important part is that the data sets. So now I have told already that in uh, our software there are a lot of data set in built in our so what you can do is that in the last class we have taken one data set of empty cars, so that was there in the R software. Now here you can see that there are a multiple number of data sets, so on which what you can do is that you can go through these data set, you can take the suitable data set and you can model it on your own, whatever we have done till now. Like in the last class we have done that lasso regression, so for that I have taken one of the data set. So here you have a lot of data set on which you can work. Now depending on which data set, so for some data sets are just there, so you do not need to have library for that. So if I will write, let's say uh, empty cars. Okay, so you have this data set directly, but there is a data set, let's say it's two. There's a data set, let's say h2, but then it is showing that there is object h2 not found, because for some data sets you need to firstly have the library of that. So firstly you need to have library, then you need to attach that h2. So if I will write h2 again, then you can get this data set. So once I have just taken that library, then you can do this. You can just see that what is the data set. Then we just attach that so that we do not need to work on that again and again. Uh, So this is our DF1. So you can see it is a large data set and you can see perform a lot of operations on that. So regarding the data frame. So now let us say that if you have any kind of data frame, the first thing you go through is that you try to find what is the summary of it. Okay, so in the summary, you can get this summary regarding minimum, first quantile, median, mean, third quantile, and maximum. You can do this uh, just for one vector also. So you need to change it in that data frame. So you can see that you can have this the summary for all the columns here, and you can have a rough idea about what is regarding the data set. Now if we move to these plots, So you can have these plots like this one is, as you can see, this one is bivariate plot. So you have z1 and you have y1, and the data points are very less here, so it is very tough to find any result from here. You can have a bar plot, you can have a histogram. Okay. So now the difference between the bar plot and the histogram is that the bar plot will give you, okay, let me tell you by this better. So, okay, okay. So, just focus on these three. Okay, let me just remove everything and then we make this. Okay, so the bar, just focus on these three plots. So, there is one histogram, and then there is one bar plot of table Z2, and there is Z2. So what is table Z2 basically? So if you have a data, so if the points are repeating multiple number of times, then if you try to make the bar plot of Z2, what is it is giving? It is giving you the bars at all the data points, which is not like which is not really important for it our case. But if you try to make the table bar plot of table of Z2, then what will happen? You can see that the frequency of 10 is maximum. After that, you have the frequency of 10, sorry, 14, and after that you have the frequency of all other, so frequency of 10 is basically maximum. If you try to make this histogram, so histogram, what it does, it basically does that in this frequency. So how many are there in between this? So in between 1 to 2, and then 2 to 3, and then 3 to 4. So you can see that for 2 to 3, so basically you have 2 or 3, and 2.5 is not here. So 3 is one time, so you can see in this table the 3 is coming one time, so there is 1. 4 is coming one time, there is 4, and then 1, 2, 3, 4, 5. So 1 is coming 5 times, so for that you have this 5. But this one works well. uh, the bar plot, with bar plot you can also understand that what is the frequency of this and then what is this. But when you have this discrete data, it is fine. But when you have the continuous data, so continuous data, that let's say I have all the values is in between 10 to 13, you can see that all are the values in between 10 to 13. If you make the bar plot of this, then you cannot get any result from here. Even if you make the bar plot of the table, because uh, then what you are getting, that you are getting just all the values, and you are getting the all are repeated just once, because these values are continuous, so you are just getting all the values. But this is not we want. We want that what is working in between these parameters. So for that you would use the histogram. So you can see that in between 10.5 to 11 you have the four values. In between 11.5 to 12 you have 1. In between 12 to 12.5 you have 3 values. So this is basically the difference between the bar plot and the histogram, which so many people just does not uh, understand exactly what is happening. Okay, now is scatter dot is smooth. So this one gives you a smooth line working with your data. So now you will get a lot of this warning messages, because see, this one is very small data set, so with just 6 points, and that also very in different way. So it is very tough to find a smooth line which works for all. but it gives it anyway. Okay. The next is that if you have a data frame and you want to find that correlation between its values, so you can have this table. What you can have more is that you can do that library core plot, and you can have these core plots. So this is, I have given the pi, so that is why it is showing in the pi form, that for all with itself its correlation is 1, and with other this one is zero point 0.5, this is less than zero point 0.5. You can see that this one is negative, so it is something. So you can see that here it is minus 0.87. Now this is zero point 0.5, this is 0.22, this one is minus 0.37. So you can have all these plots. Now here if you will change the circle, then it will show you in the circle form, and then you can practice with you. Okay, so these are regarding this uh, the basic of these plots. Then you have the repeat function. So when you try to define your data, and if you want to just, let's say, indexing or something like that, or if you want to do something where something you need to repeat, so rather than this, you can just do the repeat function. What important is that if you give the each, then it will do the each. If you give the times, then it will firstly take all the vector and then uh, repeat it 3 times, whereas for each it will repeat firstly each value. So when you have times and each and times, so both works the same way. The each works first and the times works secondary. Then you can have the sort function. You can just sort your data, and then what you can do is that you can make a list out of your data frame. Okay. So this one is not working because you have the different number of rows. So the list, you can, what you need to do is that you need to just give 1, 2 and 3, and whatever vectors you give does not matter the length of it or anything, it will just give you in that first, second and third form. So you can have different lengths of this, and you can have the same length also. Okay, so these are the this was regarding the basics of R, and that may be needed. Uh, so we have gone through this. Okay, okay. So now we will just go through our R, like why we have used this. So you have the sampling theory. So basically, sampling theory and linear regression analysis. So in the sampling theory, what we have simple random sampling. Now, simple random sampling can be done in two ways. One is the simple random sampling without replacement, and one is with replacement. So in without replacement, you just take one sample. Once you take that or let's say entry or element, once you take that element out of one sample, then you cannot take that element again. Whereas in with replacement, you have taken out one element, you can put it back, and then you can mix your sample, and then you can take again. Now, the probability of choosing a unit at any step is same for SRSWR and WOR. So, if you have, because these questions can be a bit confusing. So, you may think that once you have chosen one sample uh, in SRSWR, so without replacement, you have with replacement, sorry, you have taken one sample, that time you have probability 1 by n. Again, when you are choosing a one sample, then also you have that n element, so again the probability is 1 by n. So at any step, for without replacement it is very clear, sorry, for with replacement. But when you have without replacement, it sometimes happens that why it is 1 by n all the time. So let's say currently you have uh, n samples. So in the first time, the probability will be 1 by n. In the second time, we think that probability has to be 1 by n minus 1, right? Because now there are n minus 1 elements. But the thing is, uh, you can choose this sample only when you have chosen the first one. So that means that sample has not been chosen the previously. So that means a sample has not chosen previously, its probability is n minus 1 upon n, and it can be chosen now, it is 1 by n minus 1. So this one cancel out. So basically you have again the probability 1 by n. So this one is just for clarity. Okay, so the next thing you have is sampling unit and samples. So basically, out of the population, when you take some, let's say you have a capital N is the size of population, and you take a small n size sample, that is sample and sampling unit. So unit is as 1. So once you take that 1 unit, that will be sampling unit. Now, the probability of drawing a sample, this one is 1 upon NCN in without replacement, and is this with replacement, it is 1 upon n to the power n. So this is the example. Uh, Here are the things that how we have done is this. So this is a basic of it, that how you can do the simple random sampling, and then there are proofs etc which you can go through if you want to. Okay. The next is that you have these sampling packages in R, and then from there you can do, what we can do is that we can do the estimation of population mean. uh, so if I will try. Okay, so there is nothing like we. Okay, so here what you can do is that with the sample, uh, in the sample, what you can give is that from which this one is your population. Okay, 1 to 10 is your population. You need to define the size of your sample. So let us say I have taken it as 5. Replace is true, so you can replace the sample. And the probability, so it is depending on you whether you want to give the probability or not. If you do not want to give the probability, then the chances of getting any of that picked, it is same. But if I give the probability, the chances of getting picked increases. So here, as you can see that 3 has repeated 3 times. So because you can see that for 1, 2, 3, I have given its probability as zero point 0.2, whereas for other it is zero point 0.1, zero point 0.1. Here also it is zero point 0.2. It is not necessary that will be chosen, but there is, uh, according to like our thinking, we have given its more probability to get choose. Okay, the replacement is true. So replacement true means it is with replacement. If I will take replacement as false, then it is without replacement. Then this is sample dot int. So all you need to give here that with rather than 1 to 10, you need to give this 500. So it is gonna choose in between 1 to 500, and the size is 20. So you can see that it is gonna take any sample. of a sample of size 20 with any values. Now you can perform a lot of operations. So you can perform operations like this, and then you can take the different kind of samples. So you can go through these previous slides. So these are basically regarding the samples. So the next is that the sampling packages in R we have seen. So the next important thing is that we are doing all of these things to basically understand our population. So to understand our population, what we are trying to do is that we are trying to take a sample which defines the population, and then based on that we see what are the estimators. So estimation of population mean, so there are unbiased estimators. The estimation of population means, sorry, population variance, and then comparison of variance under these. So you can have this without replacement, with replacement, and okay. And then you can take that sample, you can have the indices of this. Now when you take the same samples, the basics basically you take, find firstly the mean, and then second is variance. If your mean is same, then it does not mean then it that it is a good let's say your mean is same for two samples, okay. But what will happen, uh, the variance can be very high. So here I have shown. So let's say you have two examples. So for 1 and 100, your no, so not for 1 and 100, 1 and 99. Okay. So now if you sum the above one, this one is also 100 by 2, so mean will be 50. This one is also 100 by 2, so mean will be 50. But here you can see that the variance is very high. It is almost in the opposite one, and here the variance is very less. So we need to find those kind of sample in which the mean is same as the population mean and the variance is very small. Okay. So the estimator you have the sample mean is the unbiased estimator of the population mean, and these are the unbiased means. Its uh, expectation of sample mean needs to be equal to the population mean, and then you need to understand how the variability is in between the sample. So you need to see that the mean is same but the variability is different. Now these are the population variance. This is the sample variance. So variance of sample mean under without replacement. So without replacement you have you it's yours, your variance can be given by this. Just a minute. Just a minute. हाँ शिवम. अच्छा अच्छा अच्छा. ठीक है शिवम, मेरी क्लास ले रही हूँ ना मैं तुमको करती हूँ. ओके. Okay, sorry for that. uh, so you have the variance under without replacement, and this one is with replacement. And you can see that here it is n minus n, here it is n minus 1. So as soon as n is greater than 1, this is gonna decrease, right? So this one will always be is less than or equal to this. So you can see that the variance uh, under without replacement is always smaller than the variance under with replacement. So that is one point you need to remember. Okay. Then this one is called as finite population correction. So if you have uh, is if you have a very large population, then what you can do is that you can replace this, because n minus n will not matter if the population size is, let's say, 1000, n is 10, then 1000 minus 10, so basically 990 by 1000, it is 0.99, it is almost equal to 1. So that time you can just write the variance by this. But if your population is finite, so a little bit small, then you need to do this correction. So that is why it is named as finite population correction. Now the estimation of population variance. So this small s square, this one is the unbiased estimator of capital S square in without replacement. In with replacement, uh, the small s square is unbiased estimator of sigma square. Now in between s square and sigma square, the difference is here it is 1 upon n minus 1, here it is 1 upon n. Okay, and the standard error can be given by this. So if the theta is the unbiased estimator of theta, theta cap, then it is not a necessary that if you take the square root of it, then it is not necessary the unbiased estimator of this. Okay, so this was regarding the basic estimation. Then, once you have found the population mean and the standard deviation, uh, so you need to find the confidence interval. Now, the confidence interval, there are two types. So, in the first one, the population variance is known. In the second one, it is unknown. So when you have it is known, then you use the z. So z test, so z test means we use the z alpha test, and we take that at 95% interval, or at alpha is equal to 0.05, what is the variance. And when the variance is unknown, sorry, what is the z value, and when variance is unknown, we use that t. So t test is used. Okay, just a minute. Okay, so here you can see that. Uh, so basically, when you have the population mean, you have exact one value, right? So if I'm saying that I will reach a place by uh, within, let's say, at a 7:10, so I can reach by 7:09, 7:11. Similarly, whatever the continuous parameters you have, so let us say the temperature. So what is the temperature? So you can say that okay, it is, let's say, 30 degrees Celsius, but it is not necessary that it is exact 30. It can be 29.7, it can be 30.3, 30.5. But if there is a difference which is major, then you cannot say it like that. So for that, we take this confidence interval. So basically, you have one interval, and within that, you take that okay, this is, if this is the interval, then we say this. So what we have is that we have some hypothesis testing. So for that hypothesis testing, we use this z test and t test. So let's just say we have this h naught as mu equal to 37. So this is the healthy body, and mu not equal to 37, this is unhealthy. Now, if someone's body temperature is 36.9 or 37.5, that one is also healthy. But according to this, it will just say that it is unhealthy because it is not equal to 37. Uh, but there we try to find the interval, that whether this value is significantly different from 37. If it is significantly different from 37, then it is unhealthy body. But if it is uh, not significantly different from that 37, then it is a healthy body. So for that, we try to find the interval, and then here, let us say the interval is defined by 37 minus delta and 37 plus delta. So if that happens, if mu belong to that interval, it is healthy. If mu does not belong to that interval, it is unhealthy. So if you have this as a sample, this population, this one as the sample, then for the normal, if your data is following the normal distribution, then we can just take it, because this is one is the symmetrical distribution. So you will have for the 5%, you will have 2.5% value in left, 2.5 in the right, and you can have these in this in between. So this is in 1 minus alpha, and then you can have uh, the interval. If you try to solve it, that y bar will come in between this. So this one is your interval, small y bar. So basically sample mean minus z alpha by 2, variance of sample mean 2, sample mean plus z alpha by 2, and variance of under root, sorry, so standard deviation of basically that sample mean. So this one is your uh, confidence interval. Now when the difference in between without replacement and with replacement is that sample mean is same, the variance is different, and this one is same, so it is known, we are using z test. If it is unknown, we are using t test with n minus 1 degree of freedom. So this one I have shown uh, that if you try to find the confidence interval here, uh, then in the q norm, so you can see that for the normal one, it is smaller, and with the t test it is larger. uh, Also the confidence, because I have said already, the variance in with replacement is higher and variance in without replacement is lower. So the confidence interval also is smaller in without replacement, and confidence interval is larger in with replacement. Okay. Now the next is estimation of population proportion and percentage. Okay. So whatever we have done, so we have done just that we have taken this sample, and this one is the basically a population. And now what we have is that we have the population proportion. So basically we write that in the proportional way. Okay, so that p and q, that are all in the proportional way. So proportional way, it is like 30%, 20%. So you can define that small pq as uh, like in between 1 0 to 1. And when you have just 2, so it is q is basically 1 minus p. So if you have, let's say, n as 100 and small p as 4 0 0.4, then you have this np, which is sample size, so it is 40. So on that, on based on that, you can have the calculation regarding the uh, population proportion or percentage. So similar will be the percentage. Now the confidence interval, finding the confidence interval is again same whatever we have done till now. The next is that stratified random sampling. So till now what we have done in the proportion, we have just divided into two. So when it is let's say 40% in this, 60% in this, so 40% population in one side and 60% in q. So if it is p is zero point 0.4, q is zero point 0.6, just divide it into two. In stratified random sampling, what we do is that we divide the population in n. Okay, that n, sorry, in k parts. So this one is n1, n2, n3 up to nk. Then in these population, we take the samples small n1, small n2, small n3, small nk. Now this summation is equal to small n, this summation is equal to capital N. The need of stratified sampling is that you, if you have a data set, let's say, and you can see that uh, that data set is basically not let's say you can do some kind of clustering in that data set. Okay, so let's say if I want to try to find about the the food quality, let's say. Okay, and then if I will just try one state overall, let's say UP. So UP is a big state. So if I will just say I have gone through some places and I will just say that the food quality is good, or let's say not good, whatever is our result. So the we have not captured it very well. So what will happen if we try to divide it in some, by some perspective? So we can divide it by the cities, that we have taken the different cities, or what we can divide is that we can divide it by the restaurant. So we are taking the restaurant, like the high restaurant with higher price, the restaurant with lower price, and in that way. So we have taken all the good, let's say, best restaurant of UP, and then we have taken some middle class and some lower class, and then we have taken all these restaurant in, and then we have taken the result from all. Then you can have a better result. So for that we use the stratified sampling. So for that, what matters is that it says that in between a strata, within a strata, there has to be homogeneity, and between the strata there has to be heterogeneity. Homogeneity means all needs to be almost same, similar, etc. Between two strata, there needs to be heterogeneity. Because if these two are almost same, what will happen? You that it is waste of time to divide it into two strata if they have the homogeneity. So that is why within like inside one strata, you need to have the homogeneity, and in between two strata or three or multiple, you need to have that heterogeneity. Okay. Now, other things are similar. What you need to do is that you need to find the sample mean, proportion mean, and then you need to see its biased or estimator or unbiased estimator. Then you need to have the variance, when you need to try to find the variance of it. Uh, and then we will have the same without replacement and with replacement. The next is that the sample allocation and variance under allocation. Now, in stratified sampling, I like, if I have, let's say, the population is divided into capital N1, capital N2, and capital NK. How we are gonna take that is small n1, is small n2, is small nk, that matters. So how I have divided, let's say, the food quality, let's say I have just said, and I have taken the restaurant. So let's say the very expensive restaurants, let's say there are 100. Okay, and then the middle one is, let's say, 10,000, and the smaller one, let's say, some 5,000. Okay, so now if I will take let's say the equal allocation. So equal allocation means take the equal number. If I will just take 20, 20, 20, so it is not a very good allocation because the population is very different. So So let's say if you have something 100 and you have something 10,000 and you have 5,000. So if I will take 20, 20, 20 from each, then it is not a very good sample because here from second and third we have taken very small sample. And if I will take the size of let's say 100, so that means in the higher restaurant I have taken all, whereas in these I have taken very less. So the other way of allocation is proportional allocation. So basically, we are gonna take in proportions. So basically, I am saying that I'm taking 20% from all. So I will take the 20% of that 100. I will take 20% of that 1,000. I will take 20% of that 5,000. So that is proportional allocation. So here the variance will be a little bit reduced. But in the last one, the optimum allocation. So optimum allocation is done. Okay, so optimum allocation is done. So you can see that equal allocation, how it is done, that all are same. So for each ni, you have capital N by just k. For proportional allocation, the small ni is proportion to capital Ni. So the constant is basically n upon n. So finally, your ni, small ni will be equal to small n divided by capital N multiplied by capital Ni. So if you have these, then if you have 100, then you can find by this. The last one is Neyman or optimum allocation. In that, what we consider the size as well as the variance, so variabilities, because we need to minimize the variability when we use this. So if you have this C star, then C star can be given by this, and final small ni can be given by this. So you can have this variance. This one has optimum allocation. Now, once you have find this, all you need to do is that find the variance under proportional allocation, under optimum allocation. So this was some example. Okay, so let us do some example from that. Whatever we have learned till now. So, which of the following statement will return a vector of all the elements of x that are not common?
Uh, I'm sorry, ma'am, I could not join today because of some that office business.
Okay, that's fine. You can just see that in YouTube if you have if you want to go through that.
Right.
Okay, so
So
this
now
one
we are
is the
working with the questions.
yeah, till now
If you,
actually I have done with the stratified sampling, and then in between I wanted to do some questions. And okay, so these are some questions. Just okay. So first question is that which of the following statement will return a vector uh, uh, of with all the elements of x that are not any?
uh, that are not NA.
Yes, so that are not any.
Was this is next. Who's that come on?
So if I will write this, x is equal to uh, c 1 2 1 2 na 4 and then na. So if I will do this, uh, x is dot na, so it is gonna give me
That was IS.
what?
Which one the command ma'am? ISNA na?
Yeah, so is dot na.
Yes.
So is dot na will
Okay.
give me which are na, right? Which are na. So we want which are not na. So for that we will have this command, that not. So for that not we use this. So
Okay, ma'am.
if I will write s is dot na, then x. So it will give me which are not na. Also, if I will write na dot omit x, then it will give me this also these attributes. So if you want to just write one, then you need to write this x is dot na x. So this one will give you which are not na. Okay. Okay. So the next is what is the output of this? Sum C, true, false, true,
Some
true.
C true, false. Please right. This it is true to result in just a moment, ma'am. What was that? What does max? Nee, what was the sum? Zero, two, ma'am. Is it two?
It is true, 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 and one false. So if I will
So
write,
okay, three true.
yeah. So if I will write sum C, so that's a true, false, true, and true. So it is 3 because what it does is that
Three,
it
okay.
replaces the false with 0 and true with 1. So it will be 1 0 1 1. So its sum will be 3. Okay. The next is which dot max table C 1 2 2 3 3 3. So when you have the table, what it does, if you have a vector, so vector is this.
Max
What
table.
what table does is that table does for 1 there is one value, for 2 there are two values, and for 3 there are three values. So this one will be your table. Okay.
Okay.
So what is the maximum value of it?
Maximum value is three.
Yes, and it is at 3. So which dot max will be
At three.
3. Okay. Now the next is which function in R will return the both mean and standard deviation
Mean and standard deviation. So, yes.
in a single line. Yes.
A single line means summary will
No.
no no. So,
The summary gives you the minimum, maximum, mean, median, uh, then the functions first quantile and third quantile.
list is not anymore. Just C mean
So list will give you in two. So list will also give you the mean and standard deviation. So list will give you
standard deviation.
as this one will come as mean and this one will come as standard deviation for when you use list. So this one is the command when you use C. the mean equal to mean of x and SD equal to SD of x. So this one
is
will
equal
give
to
you, will return you both mean and standard deviation of a vector x in one single line.
okay.
The next question is, what is the length of unique of this vector? So firstly, what will be the unique, and then we try to find the length.
Yes, ma'am. I just missed the link actually. Which one will be the length?
What will be the length? You say what will be the length. So for the unique one will give you the unique list of this. So unique one will give you C. So 5 is repeating 2 times, so its unique is 1. The Na is repeating 2 times, its unique is Na. The 6 is repeating 1 time, so this one is unique. Now if you try to take the length of it, so its length will be 1, 2, 3. So this one will be 3.
So what it was giving, ma'am? Just please repeat. I was trying in R, that this code I was trying in R, but says the initial data is not there, I think, but I could not get it.
What you have a vector, let's say. So I have a vector which is
Okay.
C 5 5 uh, Na
NA, 5
6.
5 NA, then
Okay,
5
so we have this.
6 NA.
Okay, now if I try to take unique of this, it will give me the unique value of that vector. So unique values will be 5 Na and 6, because 5 is repeating 2 times, so its unique is 5. Na is repeating 2 times, so it is 1, and then 6 is repeating 1 time. So basically it will give us unique values.
Okay,
Now,
mean the unique command is giving which is not repeating.
yeah, and
Okay,
then
which is
if
unique.
you try to find the length of this, so you can have the length as 3. So unique command will give you the unique values. So basically you can treat it like a set. So it will give you the unique values of that vector, and then its length is 3. So basically 1, 2, 3 values. So length is 3.
5 6. It's not working. Okay, length unique is 3. So what was the result, ma'am, in last question?
It was 3.
Unique. When I have run this code,
Hmm.
yeah, it is 3. So 3 is giving unique. The length is min.
The length
The
is,
result has been 3.
yeah,
The length has been third. What it is giving third? The 3.
it is giving the length. What is the length of your vector? So length of your vector can be 3, 5, 10.
The length of the vector. Okay, one, 2, 3. Right.
So unique
Okay, I
here
got this.
is
Actually, I
yes.
worked.
This one is giving this. So 1, 2, 3. So what is the length? It is 3.
Okay, three different. Okay, now, uh, 5 and the 6. You were drawing a sample of grain from population of 50 using a cells. How many possible samples exist? That was SRSW. Choose 5010. Was it choose 5010, Naman?
Yes. So it is choose 50, 10.
This was choose 5010. No.
Yes.
What was that one, man?
This was choose 50, 10.
50P10. Okay, yes.
This one is 50C10. This one is
WOR.
50P10. Yes. So the next question is that if you do the sample perform by default in R, then what will happen?
For the sample letters 1 is to 5, 3 perform by default with replacement, ma'am. No, sorry, without replacement.
Yes, without replacement. So if you
Without
do not
replacement.
give anything, it takes as without
Ah,
replacement.
by default, it takes without replacement.
The next one is that if you have population size of 100 and sample size of 10, what is the inclusion property for each unit in SRSWR? So inclusion is basically uh, not okay, like not included in that form.
SRSWR, ma'am.
Huh.
So this is B.
Yeah, this is B.
B is 1 minus 1 by minus 1.
The next question is that which
These questions will be asked in exam. I think so.
I have no idea.
I'm not making any that hint, or but just I'm guessing which type of questions may be asked.
Maybe.
Maybe
Okay.
because if R is not available, if R is available, then we can at least try any code.
Hmm.
But as you said that the R will not be available.
As far as I know, because in the last exam, it was not included. So, and also the questions we have done, so R was not, but may if they will give the R, then they will not ask these basic questions. But then also you need to remember because if you have less time, then you cannot think of like what is the syntax of this and that. So you cannot go wrong there. Okay.
Right. R functions we use to simulate this data frame. Data frame sample. Data frame sample. Replace is true. This was SRSW1 without replacement. The replaces should be false.
Hmm.
So it should be that is without replacement. Sample DF will be defined first. This which R function can be used to simulate SRSW1 data. Sample DF10
Uh,
or that.
this one will give you only once, right? uh, from a data frame. So it will give you from the whole data frame. Now, yeah, so this one can also be used, and third one cannot be used. The last one cannot be used.
Third
So
one cannot be because it is
yeah,
WR.
yeah. So the second one can also be used because this is sample. So number
Yes,
of
yes.
row comma df. So it's df, and then from 10. So it is taking 10 sample from that df. So that can be used depending on what is the number of rows of that. So this is like a vague question because 10 is not giving like what is the uh, data from data frame
Data.
dimension. It is not given, so it is a vague question, so let's just leave that. Okay, so now this is strata function is in which package. So if you want to perform this strata, then
That
which package you need to use.
survey when base that is in base function TPLR. It's a sampling function,
Yeah,
strata function,
so it is in the sampling package.
sampling function.
Okay, so for stratified sampling, uh, which of the following ensures the proportional allocation?
Proportional allocation gets equal number of samples, sample size, strata size, fixed number of samples, random allocation. If proportional is not in random,
Hmm.
for stratified sampling, which of the following ensures proportional? Each stratum gets equal number of samples. That is proportional, na, ma'am. Each stratum gets sample size is stratum size.
No.
Fixed number of samples for each all strata.
If you have equal number of samples for each stratum, then it is equal allocation. This one is not proportional allocation.
So then, fixed number of samples for all strata. Oh, yes. Proportional allocation shows proportional allocation. Each stratum gets equal number of samples. That is equal allocation. Sample size is equal to stratum size.
It is proportional, not equal.
Then
Okay, so let me just repeat this one. Okay.
sample size was
Okay. So you
proportional allocation means the
there
the
are
the sample will have proportional
hmm,
that events.
okay, so you have basically three types. So first one is equal,
Mm,
proportional, and then optimum.
optimal.
Optimal or optimum. So in the equal one, you let's say you have n1, n2 up to nk. In that, you will have n1 equal to n2 equal to nk. So basically, each strata have equal number of sample. In the proportional, you have n1 proportional to capital N1. So basically, if I have a population and I have divided into 50%, 30%, 20%, then my samples will be more from the N1. So it will be 50% from the N1 and 30% from N2 and 20% from N3. And then
Mm.
optimum allocation depends on uh, Ni. Let me write it as Ni. This depends on Ni also and Si. So Si is variance. So basically we want to reduce the variability. So it will dependent on N, the size of population and the variability in that population.
Okay.
So here, if you have equal number of size, this is equal allocation. If you have sample size, Proportional to stratum size, this one is proportional allocation. If you fixed a number of sample for all strata, so I have just fixed on my own, so that one is not coming in these three. And if you have
Hmm.
random allocation, so you are just randomly allocating, so that one will also not be
Fixed
proportional.
means to sample size, okay, strata size.
So yeah, you can just fix that.
Yeah, yeah,
Okay,
that is,
I
yeah, that is correct, ma'am. Proportionally, that is directly proportional to the stratum size. Yeah. ठीक है, that's okay.
okay. So what is the main advantage of stratified sampling over SRS?
Random sampling reduces variances within stratum. Variability is high, increases variability. No, it avoids the use of population data. No, it random chooses. It reduces variances because it is minimizing the variances of the data. No?
Yes. So basically, we take the strata in such a way that within the strata, the variability, like inside one strata, the variability is less,
Is less.
and then among the strata, the variability is high.
Yes. Inter strata, the variability will be more.
Yes.
Stratum simplified will be most effective one. Between stratum variances is low. No. Within stratum variances is low. Every stratum has equal size. Population is no. Second one, ma'am. Within stratum variation is low.
Okay.
Stratified sampling.
The next is, which of the following is true for the sample mean estimator from SRSWOR?
Which of the following is true for the sample mean estimated from the zone? It is biased. It varies depending on sample size and population values. Determining population mean. Following is true for the sample mean estimated. It, it is its variance depends on the sample size and
Yes.
population variance.
Yes. So it is unbiased. Firstly, its mean is equal to, we say, then with the population mean, and it does not uses the population mean. Whereas its variance, that depends on the sample size, because if the sample size increases, then the variance decreases.
Okay.
The next is, if x bar is the sample mean, then which of the following gives is its standard error in SRSWOR?
Is the square root by n. This will be second one. Square root n minus n divided by n minus 1 and 2.
Yeah. So if it x bar is the sample mean, then in SRSWOR, so for WOR we have this n minus n divided by n minus 1, this one multiplied by standard deviation of x, and then square root of s
Square
divided
root of
by
n.
square root of n. So this one is standard error.
Which probability ensures that the estimated conveys to the true value as sample size increases. Unbiasedness, efficiency, consistency. True value. Then that unbiasedness, ma'am?
No. So
No.
when you have the sample size, so we do not say that, if we say that if the sample size is, let's say, 10, then also we say that it is unbiased of population mean.
Esti-
If the sample size is 30, then also we say that it is unbiased with population mean. We have not learned this I think in this course. So this is basically the consistency. So if
Consistency.
yeah, so if a estimator is converging to the true sample size, that true value of sample size, so that is, we say that it is consistent one. So if we increase a sample size, it is not going to happen that it will sometimes different from the true value. It is sometimes away from true value and sometimes close from the true value. So if it is happening, then it means the estimator is not consistent in itself.
Consistency. Okay.
Yeah. So I don't think this will come. So if we have not done this, I just got some questions, so I just added this. Okay. Anyways. Uh okay. So the next question is in R, which of the statement correctly generates a bootstrap sample of size n from vector S x.
Bootstrap. That was replicate command was there one, or the BS that replicate. I just forgot that. What was that bootstrap replicate sample?
We replicate the samples, but how do we replicate?
It was boot command. Then it will be no. That boot command is not there.
We use what? Okay, so that I have done till the strata, and we can just do after that. So in the bootstrap methodology, what is its methodology? We take firstly a sample of size n from capital
Mm.
N, and this one is the original sample.
Mm.
Then we consider with replacement, and what we do is that from that original sample of size n, we
Mm.
take the sample of size n again and again. Okay, so
Okay,
we,
that
yeah, and then
yes, yes.
we repeat that process b number of times or n number of times. So that means
Mm.
we just repeat that process. So we take the original sample, and from that we take this. So here, uh,
Sample X
yeah,
replace.
replace equal to true. So this way we can just repeat it again and again. Uh, the next one is what is the key assumption of non-parametric bootstrap?
Sample data follows a Poisson distribution. Sample is representative. Population parameter is to be known. Sample is representative of the population.
Yeah, so it needs to be, the sample needs to be the representative of that
Representative
population.
population.
Uh,
Which provides a good function for the package. That package was code function was in sampling or survey. Survey, I think it was meant.
we use, I think, just the boot package, but let me see.
Just,
Okay.
let's see. Code function is
Here we have done is stratified.
in enrichment boot package.
Let me see. I also just don't remember this.
The segment collected ones.
So for
Boot
taking the samples, we take like this, and we just do it like this. I don't think we have used
package
this. Huh? Yeah.
install.
So yeah, we have used this boot package here. The boot package we have done for finding that statistic of all these. Okay.
Hmm.
So finding that, estimating the standard error, each and everything. So if I
Hmm.
will just run this command. So this boot package is giving me the standard error, etc. So this boot package will help us in estimating the standard error, etc. Now this boot function will come in that library boot.
Library boot.
So this is coming under this boot package. Now, so it is regarding the bootstrap, and then we have linear regression analysis. So this one is, I think, very fresh even. So we have done just in last class also multiple linear regression analysis. So this one
Mm.
is, uh, it is not very needed to repeat everything again.
Yes.
Okay. So this one
Ma'am,
is
I could not load the Lazo package till now. I
okay.
left it yesterday. There are three assignment questions. I have solved those,
Hmm.
but uh, I could not make it clear.
Okay.
Those
Okay.
there
So what is the
remain.
problem now?
Again, the same library unspecified. It says I
And
tried,
okay.
but yesterday I tried it, but I could not. Today I will just try again if I am able to.
What is the last date of submission?
It is I think today only. So I
Okay.
have submitted the assignment.
Oh,
There's
you
no
have
issue.
submitted already. Okay. Otherwise,
But
we.
I will, in case that these three questions I have solved those,
Hmm.
but the code I am not sure that whatever code I have utilized, is
Hmm.
it correct or not? That is the question. I have
Okay.
already submitted that. That is, let me see where this one was, because the code it has given it is failing to recognize that code. The question is number 8, and I have already done it. If your function of that R is working on that family Gaussian,
Okay. So we have these questions. This is the question.
question
And
number 8, 9, 10. I
okay.
have done it. I have find the answer that is in case of 8, 9, 10.
So how you have found these answers?
Yes, yes, ma'am. This B is right from my app. Whatever I try to write the code,
Hmm.
because if I can share my R's function,
Uh,
let me
like
see.
here, you need to run this in your R without running how you have got the answers.
I have run, ma'am, but I have taken help of the function is that I have taken help. I have tried it, but from my R Studio,
Hmm.
it is not functioning. The library function is still not being loaded.
Okay. Then how you have solved it without like library of it?
Just I was taking the values which have come. See, if I am sharing my R, what I have done.
Okay, so let me stop presenting then.
Lazo XY function. So my question was this was my code. Just- Anyhow, ma'am, I will try to get it done today. If not, then the remaining three questions will not be. I've just ticked those answers.
Okay. Okay.
Remaining seven questions I have solved it through the R, but the three questions just I take it because the codes are not there.
Okay. So because I also don't know that if it is not installing the what is the problem, you need to just you can mostly the Google it. I do not know what is the problem,
And
why it is happening.
should I write on the that forum, the Q&A forum?
Yeah, you can write that. You can take a screenshot firstly. So because they are not getting on their own that what is the problem. So you take a screenshot of it and then post it there that this is the problem happened with me and that is why I was unable to solve these problems.
Yes, that's why I have not solved. Though I have taken it, but that was just
Hmm.
making a guess. That is not the solution. So I have not solved it
Hmm.
because Lazo, I failed to install it.
Hmm. Or what you can do is that you have written this data in your R.
I have written the commands and the input data I have provided to the R.
Okay, so
All these three
you just
variables.
share that in the chat. For me, the lasso is working, so I can do that in my R studio.
Okay,
Okay.
because it's all six variables and the output I have given input to the
Hmm.
R, and I have also given the codes, the family Gaussian, whatever it is,
Hmm.
and I have
Hmm. So
completely done it.
you just
But
write
it
that
is saying yes, yes, ma'am.
all of this in the chat. You just write all of this in the chat, so I can just copy paste in my R, and then I can just do the lasso. I can just perform it here. Okay.
Okay. I'm just, should I put it now? Yeah, after the class.
Yeah, you can put it now.
Okay. Just, just temperature, area, distance, electricity, yield. These are the three, four, five, six. These are the inputs, ma'am. The variables and output, and thereafter, start.
It is coming just this. After that, it is not coming in the chat. I think this was something like maximum of it.
Okay.
Copy paste it
The
after this, or
after
you,
this,
yeah, or you better just put that two parameters. Like in one chat, just copy two parameters like irrigation level,
okay,
temperature, and then put area and this.
okay. Irrigation.
Irrigation level is x2. The temperature is x3. So the area
This one
uh,
was yield.
is x4 and distance is x5.
Now the matrix and the column data. This one was X.
Okay, so I have got x.
Yes, ma'am.
Okay, so I have got till now the irrigation level, the temperature, the area, the distance.
Yes,
So
ma'am.
the electricity. Electricity is what?
Electricity.
Number of hours. Okay, so You have not put here the this one, the quantities of fertilizer.
Fertilizer. Okay, just a moment. Fertilizer I have already. Ferty was first, ma'am. Okay, I'll just give it. Fertilizer is this one. And as per my code, was the ISO was this one. So, so if I was running the program, the code, this one was my code. What I was running.
So we have x1, x2, x3. Let me just remove all of these.
X1 to X for S6, ma'am. Six
Yeah,
variables are there,
yeah. And then y is there. Okay.
and then
So
the yield was beta vectors are corresponding to the third value. So
okay, so we have the lasso regression here.
yes, ma'am.
Okay. Now the question was
The question was what was the
standard beta vector corresponding to the third
standard
value. Okay. So standard beta corresponding to the third one. So this one is the result.
5.03. I have just clicked it unnecessarily, but
I have taken all these same, the x, y, the family, this, the n lambda is 7. So beta standard third. So this one should be this 4.28, something like that. But they have
4
not
point
given something anything like that here. Okay, what is the beta vector corresponding to uh,
third value.
fourth value of sequence of beta vector? So one, two, three, four. I have taken all of these, whatever values you have given to me, but the answer are not matching with them.
Okay. Whatever the code I have sent, ma'am, is that working? I
You
have
have,
also given what I have tried to write the code. This Lazo XY, a family Gaussian. If this works,
so you have done just n lambda is 100 rather than that 7.
yes. Some of the values are being given by the R code. Minimum rate, the lambda minimum rate is coming 1 by 0.4. That is okay.
No, it is way too far because see the beta standard, the third one, it is so small. So for the 100 there are a lot of values like 100 matrices. So it is not gonna come. But for the 7 they have given. For the
For
7
7,
it is coming 3 third value is this. What if I take 5? So I think they have done for 5, not for 7, because
for 5.
for 5 it is somewhere near 5.03, the
But
third column.
in the lecture note, ma'am, 5 it has been given because there are only 4 variables and one the output 6. 5, sorry. 4
No, that
plus
is
1,
not
5.
important. The lambda you can decide on your own. It is not necessary to give a particular one.
Okay.
The beta in this, let's say if I will take the fourth value, 0, 1, 2, 3, 4, and it is 2.35, 2.37. So this one will be correct.
First one.
Yeah. So for it, this one will be correct. For this one will be correct. And what is the lasso estimated value intercept term for the fifth value of lambda? So intercept term is a naught.
Intercept 4.30 it may be.
For the fifth value of lambda, if I will do it for the 7, let's say, then for the fifth value of lambda, it will be 5.73, something like that. That is also not here. I do not know like what is the problem with their command. Because whatever they have given, I have written the
Yes.
same, but then
Yes.
also the answers are not matching in exact form.
That one is 5.03. The ninth one is 2.37.
Yeah.
Last one the value. No problem. Ma'am, I will try to load this today.
Hmm.
I didn't get time yesterday actually, so I will try to get it again.
Hmm. Okay, you can try, but whatever code they have given, the intercept term uh, for the fifth one is this 5.73. So it is neither in positive nor in negative. It is not given in the options. So you can take the nearby value with
And in case
4.3.
of five, if we put up seven, then will there be any matter?
I
In
have
three,
taken the 7 here because whatever they have given, the code, I have taken that. Now let me just do this. So x1 is this. The x1 one thing is missed. How it is okay. The values you have given me, it is different. See, it is 6.86, 5.57. The fertilizer value you have given to me, these are not correct.
these are not correct, ma'am.
No.
Fertilizer value is x1.
Yeah.
The 6.86, 5.57.
Okay. So you have given, okay, so something missed, I think. Something is changed.
Fertilizer 6.86, 5.57,
Yeah.
1038, 991.
Okay. So there was some problem from my side. It was replaced by something else. Okay. Now let us see if the answers are coming. Okay. So now answers are coming. Okay. Fine. So now we know the correct answers exactly. Okay. So now it is for the third value, it is the same. This is 5.03. So these are the options for this fourth value of sequence of lambda. So this one is fourth. So this one is 1, 2, 3, 4. So 2.63 is this one.
2.63.
Okay. And for the last one, the fifth value of this lambda, so it is 2.82. So this one is the correct one.
Okay.
Okay. Can you update your
I will
service?
update, ma'am. The last one, I think two I have guessed. Remaining are okay. The two I have guessed, and I think last two are wrong.
Okay.
I have checked 2.63 in the ninth one and 4.30 in the tenth one. So
Okay. So
I
this one.
will amend those.
Okay.
I will try to code that today
Hmm. Hmm.
if it gets loaded. Otherwise, I will share it.
Okay. So these are the correct ones. Okay.
Thank you very much, ma'am.
Okay.
Will there be
Okay.
any class further?
No, this is the last class.
Okay, thank you very much, ma'am.
Okay, so these are some, just these are two, three questions. So this one is same, that Gauss Markov is assumptions. We use this ordinary least square estimator, and in under the normality condition. So basically, normality means your epsilon is following normal 0 sigma square. So when this happens, the MLE of slope and intercept in linear regression coincides with OLS estimates. So this was regarding this today's class, and all the best for your exams.
Thank you very much, ma'am.
Okay, thank you.